As far as a quick proof to show you that Neptune actually works, we have acquired a number of physical machines, Xeons, 8 cores, blah, 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 and a number of virtual machines are located on those. We take one of the standard Hadoop MapReduce examples, called a word count, and as you would expect, it takes an input file and tells you all the occurrences of a particular word. We do this over the works of William Shakespeare, appending to itself 500 times, giving us an input size of about 2.5 gigabytes. And as you'd expect, to get the normal nice little scale up, you add more machines, it gets faster. It is sublinear, and this is the particular aspect of the word count code itself, not particular to Neptune. The amount of overhead that Neptune adds is relatively small. You should consider it equivalent to if I ran a bash script that went and started up all these services. It's pretty much the same thing. But it's important to note that whatever characteristics your MapReduce, MPI, X10 code had before, they're going to be preserved by Neptune. We're not optimizing your code in any particular way, we're just automatically configuring and deploying. As far as the reuse techniques goes, we looked at what the cost would be to run this code over Amazon EC2 on a similar set of machines, with and without the reuse techniques. And the cost is quite dramatic. The main reason for this is that a lot of the code we ran, these are all codes from our paper, there's some context on that. The main reason for the speed ups or the improvements in pricing is that many of these codes run for much less than 1 hour. The MapReduce stuff I think runs for 5 minutes, 10 minutes on average, and simply a lot of computational time is being wasted. So this easily amortizes the cost of the machines just by simply reusing them over and over again. With that, I want to say thanks to the at-scale team who helped out along this project, especially my co-lead, Navaraj Chauhan, and my advisor, Professor Chandra Prince. at-scale and Neptune are both open source. Feel free to download them, use them, hack away at them. We're at a couple versions past what this paper was talking about. We have support for Unified Parallel C, which is a shared memory alternative to MPI, and we have support for Erlang and single node deployments. We also have a nice little automated test suite and all that kind of cool stuff, so we welcome collaborators, contributors, and so on. If you have Ruby, its Gem Package Manager can be used to install Neptune off the bat, and we have a nice little website as well. At this point, I will answer any questions, and thanks for hearing me today. Yes?
Will Neptune call me if I'm asking to do a job and I give it a constraint like spend no more than this much money, and it can't do it?
It does not do it properly for cost yet, but it can do it with respect to the number of nodes in the system. So if you say, give me 64 nodes and I only got 63, it will throw up file and give you a nice little message and say, I've got 63, you want 64. We are looking to expand this into the cost realm. Absolutely.
What about time? You say you need by TPM and it can give you 5.
Yes, that is also something that is in the alpha stage. Definitely not in the released version, but it is something you're also very aggressive with tackling. Yes?
A lot of this involves predicting the request of an algorithm before executing it. So especially given how much money it costs and their long place, what can prevent on this?
There's no real prediction in the system. It's more of a, like the scientists were talking about earlier, say, I know I have the meeting at 2 p.m. and I want to have as much of the computation done as possible. So if they can't get all 1 million simulations, it might be okay to have 700,000. So, yes, that is something where our first take on the problem is to say, get as much of the work done as possible. But in the future, we do want to be able to have the ability to say, can you do this for me? If I tried to run the code over your system 10 times or X times or whatever, is that enough information to say, could you predict if this code will work? But that is a second phase for us. But definitely very useful problem. Any questions? Great. Thank you for having us.